All right, sorry I can't be with you guys today, but we're going to talk about the Unit 6, Day 6 notes and talk about quadrilateral coordinate proofs today. So the first thing we want to do is we want to prove that ABCD is a trapezoid. So we are going to plot our shape first. 2, 8, 6, 7, negative 6, 1. We're going to label our points, A, B, C, and D, and we are going to create our quadrilateral. So if I want to prove that something's a trapezoid, you may want to have your pink sheet that talks about how do I prove something's a trapezoid? Well, we need to show that it has one pair of parallel sides. Well, how do I show that two things are parallel? Well, we need to show that the slopes are equal. So the first thing I'm going to do is I'm going to write down my slope formula. So my slope, my m, is my change in y over my change in x. Now, looking at my quadrilateral, my idea is that AB is likely parallel to DC. So what I'm going to do is I'm going to count the rise over run. So my rise 3, my run 6. So my slope of AB, 3 over 6. And I'm going to reduce my slope of AB is 1/2. Now I want to look at my other segment, my DC. So again, I'm going to create a right triangle so I can count my rise over run. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my slope of DC is 6 over 12. My slope of DC reduces to 1/2. So once I'm looking at that, I can now say that AB is parallel to DC since they have equal slopes. Now, once I know that they have equal slopes, I can now draw a conclusion. So therefore, ABCD is a trapezoid. And my reason that it's a trapezoid is since it is a quadrilateral, with one pair of opposite sides parallel. Now the second part of the problem says, prove that it is not an isosceles trapezoid. So my plan is to show that two of the legs, right, or the non-parallel sides are not congruent. So if I want to do that, I can use either my distance formula or my Pythagorean theorem. And you guys know that I prefer the Pythagorean theorem. So what I'm going to do is I'm going to go back and I'm going to look at my non-parallel sides and I'm going to figure out how to make these into a right triangle. Okay, so counting 1, 2, 3, 4 over 2. And while I'm up here, my other one as well. My BC is 1, 2, 3, and 4. So now I'm going to use those numbers in my Pythagorean theorem to find the length of AD and the length of BC. So if I'm looking for the length of AD, we've got, so first I'm going to write my formula. A squared plus B squared equals C squared. So 2 squared plus 4 squared equals my AD squared. So 4 and 16, AD squared. There's my 20. So I know the length of AD is radical 20. No need to break that down at all. So now let's talk about BC. The lengths of my right triangle. 1 squared plus 4 squared was BC squared. So 1 and 16 together, that's going to make 17. So BC is radical 17. So therefore, my AD is not equal to BC. So now my conclusion is that trapezoid ABCD is not isosceles, since the non-parallel sides